Hi guys, my name's Ian, and this week we're back with Paul McWhorter's Arduino with Python series. This week is lesson 15, and we have been playing with a ball bouncing around a box. Now, if you recall last week from my solution to lesson 14, I had a couple of balls bouncing around a couple of boxes, and there was a tunnel between the boxes, and the balls could change which box they were in. Now, at that time, I hadn't got my head around some of the physics and the 3D-ness of the ball having a radius, so I'd got it working without a radius. Well, clearly that wasn't going to last. I have to deal with the radius of a ball. So this week I'm back, I've solved that problem, and I've extended the demo, and it's all fully parameterized, so let's have a look at some stuff. So, what you can see there is what my demo is. I've got 4 boxes linked with 3 tunnels. Now, the boxes are all strategically positioned to give me something in the X, Y and the Z direction. So I've got a tunnel in the X direction, a tunnel in the Y and a tunnel in the Z. Last week it was just a tunnel in the Y direction. That's the tunnel linking an upper and a bottom. But there's now a tunnel in the X, which is linking a left hand and a right hand. And then there's a tunnel in the Z, which, if you can look behind the lower box, there's a box behind it as well. Anyway, that's just to give you an idea of what the 3D-ness is that we're playing with. Now let's have a look at some code. So, here we have it. The code's quite different from last week. And it actually does look like, oh my god, how much code is there? In actual fact, there isn't as much as you think. It's just that there's a lot of almost repetition of it, because you've got it in multiple rooms, multiple tunnels, and multiple axes. So it's the same sort of stuff, just again and again, just for the different rooms, the different axes. Anyway, we still draw a box, build a box. This is where we draw what I've been calling arenas. That hasn't changed since last week, although some people have appreciated the fact that I've called it X, Y and Z. So that's the box. The tunnel is a little bit different. It's a little bit more sophisticated. Quite simply, what it's doing is it's drawing a tunnel in the correct axis. The reason it needs to know the axis is because at the ends of the tunnel in that axis, it doesn't draw any walls, just to make it a tunnel. It only draws the outer walls. So, for example, a tunnel in the x-axis wouldn't have a left hand or a right hand wall, but it would have the top, bottom and the front and the rear. That's what this sort of does, and it's simply replicated for the y and the z axis. Again, it's returning the parameters, and this becomes interesting. These parameters are telling me it's used later on in the code to check the bounds. This is the bounds of the box it's drawn, or the bounds of the tunnel it's drawn, and we've got the x, the y and the z bounds, and then we've got this side is the left hand for x, or the right hand, or for the tunnel it's the bottom, or the y, it's the bottom of the top, z is the rear or the front. The important bit to notice is it's the minus or the plus, so that's where it's important. Now let's draw some arenas. We've got 4 arenas, so we've got 4 sizes. The first 2 are set sizes, just like last week, and the second 2 are related to the first 2. That's how we're doing our parameterization. This is drawing the arenas. We work out the center of it, and we basically build it and get our bounds back. The center of it is, I'm doing some stuff with offsets here, and basically that's moving it around in the axis so the boxes aren't all on top of each other, and then it passes over the size. So this creates our four boxes, right, our 4 arenas. This links the tunnels. This creates the tunnels that link the boxes. So there's 3 tunnels, X, Y and Z, and similar sort of thing. I'm working out how big the tunnel needs to be. This is working out the distance between the two sides of the arenas that the tunnel is going to be between, and that's obviously the distance between those two sides. So it's the for example, in this X tunnel, it's the right hand side of one box and the left hand side of the other box, and the tunnels in between. So that's what we've got, and that's working out the distance. And there's a similar idea for the Y and the Z tunnels. The important thing to note here is the sum has to be correct. So we're subtracting a larger number from a smaller number. In fact, if you subtract the smaller number from the larger number, you still get a tunnel. It looks right, but on the screen it looks absolutely perfect. But the dimensions, the bounds of it are wrong, so it messes up the logic and testing below. So make sure it's larger minus smaller, gets you the correct sizing of number in the for use later on. Anyway, that draws the tunnels. Then we have the ball. Last week we were playing with the ball having a random direction, which in fact I was playing with as well. However, it turned out that in one of the runs this random direction was created, and that vector was just perfect. It allows the ball to visit all the rooms in not too long a time period. So I've just kept using this one because it's a really good example that shows the ball starting in my case it's starting in Arena 3, which is the one on the upper right hand side box. So the ball starts there, and with this vector it will within a few minutes have visited all the other rooms through all the tunnels. This prints me out some information. I was using that to check what I was what bounds I was getting back and what the ball was doing, and that was allowing me to manually do some of the calculations, which we are almost at. So what sort of calculations do we do in this loop? Well, this is the stuff that looks, oh my goodness me. Right, but let's break it down. This just looks a lot because there are 4 arenas and there are 3 tunnels. But it's the same sort of calculation for each one, just using different bounds and different axes. So what is it doing? Right, well the first thing we do is we decide we haven't worked out where the ball is, so we set all these flags to false. And then we basically go through each if statement, effectively working out if the ball is in that room. Now, if the ball is in that room means quite a few things, right? Simply, the ball has 2 edges. There's in the x-axis there's the left-hand edge and the right-hand edge, and this is the bit that was confusing me last week. What you have to think of, if the ball has got 2 edges, it makes it perfectly possible for both edges to be in one room, or in fact one edge to be in one room and another edge to be in another room. So what we're doing here is, if you take this whole if statement, break it down into thirds. So this is doing a test in the x-axis, this is doing the same sort of test but in the y-axis, and then this is doing the same sort of test in the z-axis. And what it basically tests is, where is the ball's edge, or rather where are the ball's edges. The ball's got 2 edges, and a box or an arena has got 2 walls. So this is simply testing, well, is one of the edges within one of the walls, and same for the other edge of the ball, and checking it for the other side of the arena. So this is doing the test on one side for the ball with each side of the radius, and then this is doing the test for the ball on the other side of the arena, each side of the ball. So that's where you get it. Two walls, 2 edges gives you 4, 3 axis gives you the 12 conditions, and it's the same stuff all over for the other arenas. It's just working out, is any part of the ball in that arena, and if it is, it sets it to be true. Does the same test for 2, 3, 4 and each of the tunnels. Now, it's perfectly possible that, in fact, when you're moving from one room to another, it is certain that a ball will at several stages be in two places. It'll be, if it's moving from arena 1 into arena 3, it's got to go through the X tunnel. Therefore, at some point in time, it will be one half of the ball, or one edge of the ball will be in arena 1, and the other edge will be in the tunnel. Equally, when it's exiting the tunnel, we'll get the same again. One part of the ball will be in the tunnel, and the other part will be in arena 3. So it's possible that a ball, when it's moving through tunnels and from one room to another, will be in two locations. One half of the ball in one location and the other half in the other, or not halves but fractions. So that's where the next testing comes in. Imagine the ball is going from arena 1, which is the top left, and it's going to arena 3, which is the top right. There's a tunnel between them, that's the X tunnel. So if I flick back to this, you can see X and the two arenas at the top linked by a tunnel. The left hand arena is arena 1, and the right hand arena is arena 3, and it's linked by a tunnel, which is the X tunnel, and that's what we're looking at the moment, the code for that. So what does it do? Well, quite simply, it's worrying about the direction. So if we're going for, if we're thinking we're in arena 1 and we're in the tunnel, what we have to work out is whether we are leaving the arena or tunnel. And what it does is it checks the change vector. This is what the ball, this is the direction the ball's moving in. So if we're in both arena 1 and the tunnel X, but our change is less than 0, it basically means we're traveling from right to left. Therefore, we must be going from the tunnel into arena 1. And if that's the case, we've set the bounds of the area we're interested in to be the arena we're going to. If, on the other hand, the change in X is greater than 0, then it means that we're leaving arena 1, going into the tunnel, so we set the bounds of where the ball's going, which is the tunnel. And at the other side, when it's entering or exiting the tunnel from arena 3, we've got a similar sort of calculation. Are we leaving the tunnel going into arena 3, or are we leaving arena 3 going into the tunnel? And then we have this repeated many times for the other arenas. That you've got arena 1 going to arena 2 via the Y tunnel, and you've got arena 2 to arena 4 via the Z tunnel, and it's doing the very same sort of checks. Where is the ball going? So it's taken into account the change vector. Is it positive or negative? Because that tells you in the X, it tells you whether you're traveling left or right. In the Y, it tells you whether you're traveling up or down. And in the Z, it tells you whether you're traveling forwards or backwards. So once it's actually worked out where the ball is going, then it makes it go there. And that's moving the ball. So the ball's position gets updated with the change. And then this is the boundary detection. Do we bounce? Well, of course we bounce off the walls. But the extra check, because we can be entering and leaving boxes, we only want to bounce off a wall if we're actually going towards it. So you imagine the ball has just entered arena 3, come out of tunnel X into arena 3. Well, at that point in time, this code might think that it's close to the wall, or maybe even touching the left-hand wall of arena 3 in the X direction I'm looking at. So it might think, oh, I need to bounce it. But it takes into account the fact that the ball is actually moving away from the wall. Therefore, it doesn't need to bounce. It's already moving away from it. So this boundary detection just checks whether you're near or touching a wall, and whether you're actually moving towards the wall or away from it. And only if you're moving towards the wall will you bounce. And that happens in the X, the Y, and the Z. So that's all the code. We'll have a demo, and let's see what this looks like in action. So let me fire it up. So here it comes. It's running up. It'll print me out that information. So there we go, that's the information that I was talking about. It prints out all that stuff, and that's actually quite useful to work out what the structure looks like. Now let's see what it has drawn. There we go. If we turn on Firefox for you, there we are. So there's the ball moving around. It's already moved around some rooms. You can see the rooms here with the linking. So there's the Z tunnel we can see just here. This is the Y tunnel. This is the X tunnel. This is Arena 3. That's Arena 1. This is Arena 2. And the one at the back is Arena 4. And I think you can see the ball has just moved from Arena 1 into 2. And we watch it for a moment, see where it's going to go. And it's going back up to Arena 1, and if we zoom in on that, you can see that it is bouncing on the edges as opposed to the center of the ball that it was doing last week. So there we go. Any questions? Use the comments below. This code will be in GitHub as usual, and enjoy.